to my project. My project is data serialization Avro and sequence files in big data or hadoop environment. The objective of this project is to learn about the Avro and sequence files. Now, as you know, the data serialization is a process. Data serialization, deserialization is a process of converting object type into byte stream and vice versa. Now, what I have done is I've used a simple word count example to understand Avro Java APIs provided by the Apache. The required jar files are already available under the Cloudera Kickstarter VM. The Cloudera Kickstarter VM can this is the Avro files. The Avro is bundled along with the Hadoop in the Cloudera Kickstarter VM, and so the JSON API jar files, which are also bundled across. JSON is the format which as a schema evaluation Avro uses. The first example which I worked on was word count, just taking a basic file using using the key value pair as defined within the Avro schema, and then giving the output. So the code is basically basically just a map reduce which I have used, reading and reducing it. But in the reducing part, what I've done is I have done a null writable, as I will show you here. Null writable. What I'm saying is I am not going to write anything. So I'm going to put the input and the output, and see how it is being written into the file. So this is I have already built the jar file, which is under this is the jar file. Currently I have a couple of input files. Input file is either all Bible or problem1. We'll take the all Bible, which is smaller, so we can so now this is starting, the user Cloudera input problem .txt is the one as the input, and the output is being written to area 1. So this is a map reduce job. So it's a single node cluster. It's not a cluster, it's just a single node machine which I'm just using. If I have a bigger file, then maybe I could have used a cluster. It will take a few minutes before it starts, if it stops. And what I'm expecting is a key value pair. Yeah, it's finished. So just we will have a quick check on the output. One. So that's the output, and that's the success, which shows that it has been successfully done. successfully read the file and then did the key value pair, which is basically word and the count. So if I do a top so I'm just going to look at top output. Okay. So that's the one which it is doing. So it says this is the key, it is my schema, you can call it as a schema, and that's my value, which is 1. So this is problem1.txt. We can use, similarly I can still use all bible.txt, which is, and then this one will be a bit more quicker because it's a smaller file, whereas problem1 was around 6, just more than around 60 meg, whereas this is around 5 meg. So this one will do is a different file as to the other one. The other one was a kind of a patent citation text file. Yep, so if we check whether we, so once we've done that, we just cat it and see how much we have. Yeah, as you can see, this key, and we can still kind of look. So this is what I was trying to look at, and what basically the Avro comes up with. Avro does is it's language independent, so you can write a schema, and that's kind of a metadata per your file, and you can then talk across multiple languages. So, and also if you can add, if you have added an element to that schema, then the clients don't have to know, if they can just read the old one, they don't have to have the new one, which is kind of an advantage for Avro. And you can also do remote procedure, although I haven't actually done this, but that will be handy when handy. And now I'll look at is the next one is the sequence files. Now the sequence files is basically, it's a binary data, and it has but it is implemented using Java within Hadoop, so it's not language independent. That's one of the limitations for sequence files. So there are 3 types of formats within a sequence files, which is uncompressed format, record compressed, and block compressed format. Now this header will be same across any of these formats, and the header is simple 3 byte, what's the version, and then you have multiple metadata about that particular file. Now what I've done is I've just did a simple example of reading a file, creating a sequence file, which is basically a binary file, and then reading that binary file and then outputting on the screen. Okay, so the first one is reading a file. So now I am at, so I have already generated 2 jar files. The jar file to read a file, and then write a sequence file, which is just a binary file, and then you can use the other jar file, which is the read.jar, which actually reads um, okay, what we'll look at first. We read a normal file, text file, then write a sequence file, and then we'll read the sequence file and then output the contents as text on standard output. Just to be different, I've done that. So this is again a basic simple example of how to work with the sequence file APIs. So now this is my write.jar. So I'm going to use what I'm doing is the Hadoop will read this jar file, this class within the jar file, and then it will take the input as it will take the input as a local one, and then it will write the output file. So what it is going to do is the jar file will take this file, and then input will be problem1.txt, which is already on my local file system, not on Hadoop. And then I'm going to write the sequence file onto the Hadoop file system. It's just kind of making it so just started it, so it has started it, and then so I still output it out on the standard out anyway. That's just reading the existing file. That's finished now. So let's see whether it has created. Okay, so that's the one, that's the file, and now if that is the file it just created, and if you just cat it, then it will be a binary file which will just show different characters special on the screen. So that's what it is. Okay, close. So now we will look at the other one. The write file, the read.jar. What the read.jar is, which will take care of you'll read that sequence file which we have created, and then it will just output it on the screen. So this is my read.jar, and my sequence file is this one, and then it will just output on the screen. Okay. So just working with the existing input and the output, and you can actually use the Hadoop command itself to output. I mean, you can output the same thing using the Hadoop command. You don't have to write if you already know that the actual file which the sequence file is generated from is a text file. So if you know that attribute of that file, you can actually use a text casting, and then you can show it. This is basically it. this is what I've done. The main the things I've learned from this small little exercise was that Avro is more powerful and with its language independence, and also that schema evaluation, which comes in very handy. And as Hadoop is more of a distributed and parallel processing in an Arctic environment, the amount of time taken to execute a particular job versus the space, they go hand in hand. This, if it is more space, then the time required to process it will be more. If it is less space, time taken to process it will be less. So any binary formatted data will be the binary data is always lesser in size than the actual data structure which was created out of the binary data. So the if the programs are talking to each other when they're encapsulating the data which is as close as to the data structure, then both time and space will be reduced, hence hence the applications will be more efficient. Thank you very much.